Let me share this video with you how to wire the ammeter and current transformer wiring. First of all, there are two types of ammeters. One is the straight-through type and the other is the current transformer. How do we tell the difference between the current transformer type and the straight-through type? We can look at the markings in the lower left corner. It's labeled 100, 5 or 300, 5, something like this. That's the current transformer type, and then there's 20 amps. 30 amps, 50 amps, 100 amps is a straight-through ammeter. Let's first look at how to wire a straight-through ammeter. There are two screws on the back of the ammeter. We can put these screws in series with our wiring. For example, there's a heating rod here. We'll start by connecting a fire wire and give it a switch. So when we close the switch on the heater, in the whole circuit, we know that the currents are equal in series. Put the two screws of the ammeter directly connected in series in our circuit. He can display the current level of our current because the currents are equal in a series connection. But because it's connected in series, if the power of the heater is high, so our through-type ammeter, it is generally only suitable for small power loads. For example, 20A, 30A, 50A. Its maximum specification is not more than 100A. Our normal ammeter, usually the pointer will be at half or 2/3 of the way. So we are talking about 50 or 60 amps. We can use 30 or 40 amps. If it's more than 70 or 80 amps, we'd better use the current transformer type. This is the straight-through wiring method. There's also the current transformer type. The current transformer type is the same. There are two screws at the back only. The marking here is a proportional form transformer. We first look at it. Has a watt. It has the current ratio is 100, 5, there's 200, 5. When we choose the ammeter and the current transformer, the ratios here should be exactly the same before we can use them. Let's see how it's wired. First, there are two screws, S1 and S2. After we remove the screws, leave two terminals. Then, we can connect the wires. Connect the two terminals S1 and S2 directly to this one. These two terminals are connected in series with our ammeter, and it has a P1 and P2. This is P1, this side is P2. Be careful when threading the wires. P1 side is the incoming wire, P2 is the outgoing wire. Let's say this is a current line, and the current is very high. It's about 70 amps. When we thread the wire, we first put this hole in the center. We first put our wire in from the P1 side, and then come out from P2 side, that is, if it's one of our current transformer. There are two screws here on the left side. Is the incoming P1, this side is P1, the outgoing side is P2. Don't reverse this. These are the two terminals of S1 and S2. Then let's see how to wire it to the ammeter. For example, there's an ammeter here. These are its two terminals. We can connect S1 to this terminal, and then S2 is connected to this terminal here. S1 is the two terminals of the ammeter. It's straight through, so S1 and S2 will form a circuit. The ammeter will generate a current value. The current transformer has a current ratio of 105. What does this 105 mean? It means it can reduce the current of our primary core penetration 20 times. Smaller 100. 5 means 100 divided by 5 is 20 times. If it's 205, that's 40 times smaller. Let's say we are here. He's showing the actual current, it's 80 amps. After it's scaled down 20 times, it will show with a current of 4 amps after the current is reduced by a factor of 20 after the output. Our ammeter, it's scaled down by a factor of 20. The ammeter also has a multiplier of 105. The 105 here is 20 times amplification. It's a reduction of 20 times. After passing 4 amps of current here, we need to amplify it 20 times in order to match our original value. What's 20 times magnification? That's 80 amps. First, it's scaled down 20 times by the current transformer. And then through our ammeter, we amplify it 20 times. So that what our ammeter shows will match the actual current value. The wiring of the ammeter in terms of regulations S2 must be grounded. For our safety, this meter has 105 amps. That's the maximum current it can pass, that's 5 amps. So when you are choosing a wire, you can choose 1 square of wire is enough, because each square can carry 6 amps of current. But there is a specification is not less than 2.5 square wires. When we choose the wire, you can use 2.5 square wires from here. Then you can use it. This is the wiring of the ammeter and the current transformer.